Welcome to our lesson, Doing Math in Python, and in this lesson, what we're going to do is that we're going to calculate correlation between two data sets. So what is correlation? So correlation is also called Pearson correlation coefficient, or just correlation coefficient, measures the strength of linear relationship, and the value of this correlation can either be positive or negative, and its magnitude can range between -1 and +1, and this is inclusive. So when the value is +1, then it has a very strong positive relation, and when it is nearing 2 or -1, exactly -1, then it means that the relationship or linear relationship is strongly negative. So when the value approaches to 0, then it means that the relationship is becoming weaker, and 0 means there is no correlation. So correlation does not imply causation. This is actually a very famous concept in statistics and in data science or even in machine learning. So not all relationship would mean causation. Say for example, we would say that a lot of people going out to see a movie, it does not mean that there would be an increase in the sales of jacket. In other words, this can be just a coincidence. So when you study, there is high correlation between the sales of jacket and the increase of the number of people who go into movies. That does not mean that there is correlation. The going into the movie houses does not mean that it is a direct cause of the increase in sales of jackets. So here we have the mathematical formula of correlation. How do we calculate correlation? So we have this different elements in our formula. So we're going to have them one by one. EXY, or the summation of xy. So this is the sum of the products of the individual elements of the two sets of numbers x and y, and we can find that here in the numerator. And when we say summation of x, this is the sum of the numbers in set x. You can see that here in the denominator. Summation y is the sum of the numbers in set y. You can find in this part of the denominator. Ex, or summation of x squared, is the square of the sum of the numbers in set x, so you can find it here. And in this one, the summation y squared, you can find here, is the sum or square of the sum of the numbers in set y. What about this one? So this is the sum of the squares of the numbers in set x and y. So now how are we going to do this one in Python? So we have this, and what we do here is that we define, or we have the mathematical translation of each element of this formula. So for this one, for this, for this, for this, for this, and then for this. So what we do first is that we import numpy as np, and for example, we have these values for x and for y. We get first the length of x, and then here we get the sum of xy. So for that, we would be able to calculate this part of our equation. That means n, the length of x, or the number of the elements in the list x, or even y, or in a data set, I mean, then we have the sum for x I times xy for each element in x and y. So for example, 5, 4, 3, 6, 5, 3, 7, 6, 8, 9, 7, 8, 5, and 6. And then that is here, right? So we get the summation of this x times y. And then what we do here is that we minus that, or we minus the summation of x times the summation of y. So how do we do that? So this part of the equation, or is the translation of a mathematical part of this formula. And what about this denominator? How do we do that? So we do that per element. So this one is for this part of our equation, and for this one is for this part of our equation, and then we get the square root by multiplying everything to 1/2. So we are going to execute this, and there you go, guys. So the value is 0.61. So this is the value of our correlation. So this means that we have a strong positive correlation. So which means that as x increases, the value of y also increases. So for better understanding, it's better to have this one plotted. So let's have, okay, this. This scatter plot would give us a hint of the existence of the correlation between sets, and we can also identify whether there is a positive correlation or negative correlation, and either of them would be strong or weak correlation. So let's execute this. Okay, so now there you go. So as you could see, there is a positive correlation, strong positive correlation. So if we're going to make a line, then this can be here. Okay, so that's it, guys. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.